A circle is a set of all points that are the same distance from a fixed point called the center. The distance from the center to any point xy on the circle is called the radius. In the diagram, a right triangle is formed by drawing a horizontal and vertical segment from the center to a point xy on the circle. If the center of the circle is at the origin, then the length of the legs of this triangle are x and y, and the hypotenuse is the radius r. By the Pythagorean theorem, the square of the hypotenuse is equal to the sum of the squares of the legs. So we get x squared plus y squared is equal to r squared, where r is the radius. If the center is moved to a new point, we adjust the equation to account for this shift. The standard form becomes the quantity x minus h squared plus y minus k squared is equal to r squared, where hk is the center of the circle. This equation represents all the points xy that are fixed distance r from the center hk. To find the center and the radius of a circle from its equation, we start by comparing the given equation to the standard form of a circle. We can rewrite x plus 3 as x minus negative 3, which shows us that the center is negative 3 and 4. On the right side of the equation, 49 is the square of the radius, so the radius is the square root of 49, which equals 7. In the second example, the equation is x squared plus the quantity y plus 5 squared is equal to 11. This is the same as x minus 0 squared plus y minus negative 5 squared equals 11, which tells us that the center is at 0, negative 5. Since 11 is equal to the radius squared, the radius is the square root of 11. Write an equation of each circle and sketch its graph. What are the domain and range of the relation? To write the equation of a circle, we start with the standard form. The circle is centered at the origin, which is the point 0, 0, and it has a radius of 4. Plugging these values into the equation, we get x minus 0 squared plus y minus 0 squared equals 4 squared, which simplifies to x squared plus y squared is equal to 16. To graph it, start by plotting the center at the origin. The easiest way to sketch the circle with a radius of 4 is to move 4 units in each direction, up, down, left, and right, to create a basic skeleton. Then draw a smooth curve connecting these points to form the circle. The circle stretches from negative 4 to 4 along both the x-axis and y-axis. Therefore, the domain of the relation, which represents all possible x values on the graph, is negative 4 to 4, inclusive. And the range representing all possible y values is also negative 4 to 4. How about a circle centered at negative 3, 5 with radius 5 halves? We use the standard form and substitute negative 3 and 5 for h and k, and 5 halves for r. This simplifies to the quantity x plus 3 squared plus the quantity y minus 5 squared equals 25 fourths. To graph the circle, start by plotting the center at negative 3, 5. From there, move 5 halves units or 2.5 units in each of the 4 directions to mark the outer points of the circle. Then draw a smooth curve connecting them to complete the circle. Looking at the graph, we can determine the domain and range. X value stretches from negative 5.5 to negative 1/2. The range goes from 2.5 to 7.5. You can also find the interval by subtracting or adding the radius to the coordinates of the center. To verify that the given equation represents a circle and to identify its center and radius, we begin by rewriting the equation in standard form. The original equation is x squared plus y squared plus 4x minus 8y plus 4 equals 0. To rewrite it, we group the x terms and y terms and move the constant to the other side. Next, we complete the square for each group. For x squared plus 4x, we add 4 so that we can complete the square as the quantity x plus 2 squared. And for y squared minus 8y, we add 16 so that we can complete the square as the quantity y minus 4 squared. To maintain equality, we also add 4 and 16 to the right-hand side. So we get 16. Now this is in standard form for a circle. This confirms that the original equation is indeed the equation of a circle. From this form, we can identify the center of the circle as negative 2, 4, and the radius as the square root of 16, which is 4.